If two pairs of corresponding angles are congruent, then the triangles are similar. So that's a shortcut for you. Instead of having to prove all three angles congruent and the side lengths proportional, all you have to do is prove two angles and you're done. So in this picture, A is congruent to D and B is congruent to E. So that is enough information to say that those two triangles, ABC, is similar to DEF. Okay, on these first three problems, you are deciding if the triangles are similar. If so, we're going to write a similarity statement. And you also need to explain your reasoning. It's not always going to be super obvious just by looking at it. You sometimes will have to solve. So here, obviously, we have A is congruent to D right now because you have right angles there. Why? Not A is congruent to E, excuse me. Because of right angles, so that's one, but you need two. So can you guys please solve for the missing angles here to check and see if we have two angles that are congruent. So if you need a calculator, get out your own or grab one from the back. Triangles sum to how many degrees? 180. Hey Luke, will you take your headphones out? We'll take notes. We'll take notes. So you're solving for those missing angles to see if we have at least two. Brooke, what do you got for angle C? 75, that's good news. And so angle F, Abby, what's angle F? 15. You actually have all three angles congruent. That's more than enough information, but since you're explaining your reasoning right now, just tell me one more pair. So angle B is congruent to angle F. Since you've said that two angles are congruent, you can say that they are similar. Remember, a similarity statement is where you say both triangles. So triangle ABC, that was not a triangle. Triangle ABC is similar to triangle. It's not DEF. The order of the letters matters. If you did ABC, you have to do EF D. We go by the corresponding angles, not by alphabetical order. Number 2, go ahead and find the missing angles there as well. So if we know the triangle sum to 180. So you're finding your missing angles. You can do 180 minus 99 minus 21 to figure that out. Please do not assume you know what they are. Actually solve. Cooper, what's angle Y? It is 60. And we also need angle, whatever this one is. It doesn't have a name. Anybody have that? 98. So you have one angle congruent. You have that they both have 21, but you don't have two. So these are not similar. You do not have enough information. Bummer. Okay. And then number 3. You already have one. You can't solve for the other two right now because you You would need 2 triangles to find the third. But how could I prove these triangles similar? Vertical angles. Nice. These 2 in the middle, which we could call 1 and 2 if you want. Just to make it easier, angle 1 and angle 2 are congruent because they're vertical angles. You also have P and T. So that's enough information. You have 2. Angle similarity says these 2 triangles are similar. So triangle QRP is similar to triangle SRT. Whenever you're ready, I need you to find the missing angles for number 4. You're solving for the missing angles right now, so if you know whether or not they are similar. Aiden, what's angle E? Okay. Luke, do you have angle A?
I got 34 degrees.
Okay. Are these 2 triangles similar? No, only one angle, you have to have 2, so not similar. Again. And one more here. Number 5. No angle markings, but you do have these little arrows on the side. What do those mean again? Parallel lines. And what's the most common angle pair that we look for when we have parallel lines? Alternate interior angles. So let's start with these 2 lines, PQ and, I keep saying lines, these 2 segments, PQ and SR are parallel. And so these 2 that are touching the transversal, angle 1 and angle 2, we'll call them, are congruent because they're alternate interior. You do have another set of parallel lines if you'd like to turn your head. These 2. So these other 2 angles happen to be congruent as well. Because you have 2 sets of parallel lines, those are also congruent. They are similar. You have 2. We can say angle 1 is congruent to angle 2. Angle 3 is congruent to angle 4. Therefore, the triangles are similar. Triangle P, Q, S is similar. That would have to be R, S, Q. Your order matters. Because with the bottom of this page is kind of fun. I mean, there's a lot to it. Oh, little parts. Right now, you do not know that those triangles are similar. When I say those triangles, I'm talking about these 2. We're going to need to figure that out in a second, but right now, we don't know for sure. So let's just go ahead and start with finding things in this list. Let's start with AGB. That's this angle right here. You know that the other 2 angles in that triangle are 90 and 63, so solve for AGB. Aubrey, what would it have to be?
27.
Would have to be 27. Because those 3 have to add up to 180. I keep doing the eraser. There we go. So this one is 27 degrees. That's AGB. Next one on your list is EGD. That's the one directly across from it. What kind of angles are these? Vertical. So that EGD is also 27. Okay, so that's the two we have so far. Both lists, both the first two in the list are 27. The next one is BCG. Actually can't really do that one quite yet. We'll get to it in a second. Let's go ahead and find what's this angle right here have to be. You have 2790. What's the third angle have to be?
63.
63, because it adds to 180. Okay, now we need to go back and ask ourselves the question we had before. Are these two larger triangles, are they similar? In order to be similar, you have to have two congruent angles. You have one, you have 63. So right here. 27 does not count, however, because 27 isn't the full angle for that triangle. These two are similar, yes, but I'm talking about the two larger ones. So these two. How could you get a second angle for those? Okay.
You get 63 for angle C and angle F because the BE is the median line. So it passes through G and has right angle.
Yep, so you can do that. You can call this one 63 as well. And then this will be 63 as well. That works. What's another thing that we could do? Yes, but they're not a part of these two bigger triangles. They're inside of it. What about these triangles? Are they congruent? Vertical angles. Okay. So yes, they are similar. And as Sam said, you can go ahead and say that BCG is 63, because that would have to be in the middle. Okay. So that's 63. That's this one right here. Next one on your list is AG. We'll get to that in a second. We know these two triangles are similar. The altitudes here go from 3 to 6, so they're multiplying by 2. So if this side is also 3, what is this one? 6. So this entire side is 6, which means that this section has to be AB is 3. So AB is 3. Likewise, you know that this whole part, FD is 3, so it cuts this into 2 sections since that is the median. So FE and ED both have to be 1.5. Okay. So the only two things that you have left to solve for are AG and GF. You have a right triangle, and this is your hypotenuse. So what do we use to find this side? Pythagorean theorem. So 3 squared plus 6 squared equals whatever AG is, C squared. You solve for that. You will also do the same thing to find GF, which is a part of another little right triangle. 1.5 squared plus 3 squared equals c squared. So solve both, please. We're going to get 45. I think AG is about 6.7. And then when someone gets the other one, can you let me know? Sam, what do you got?
Wait, sorry. I admit square root.
Okay.
It's 3.35-ish.
Okay. We'll say that. Which makes sense, because it should be half, since the scale factor was 2. These triangles are similar. AGC is similar to triangle DGF. Ooh, okay, I know that was a lot. The word type, they're not word problems necessarily. The problems in the back are like things in, I guess you could say, real life that make similar figures. So one way that you can get similar figures is by putting a mirror on the ground, which is what you see in this first example. This thing right here is actually a mirror. I'm sorry this didn't print out super well, so I'll write in the lengths again. What you do is you look at the mirror and then line yourself up so you can see the mirror, the top of the figure, and the mirror. And what it does, it makes congruent angles right here, and since you should be standing straight up and down and so should your object, you have 2 angles. So they are similar. You got 16 here, 8, and 6. We are solving for x, the height of the tree. Okay, so how tall is the tree? Could do x corresponds with what? The height of the tree corresponds with the height of the person. And then this part of the tree, not part of the tree, distance to the mirror would be 16. Distance the other direction is 8. So just like we do with just the regular polygons, you can solve these with proportions. Cross multiply and solve. I think you get 12. So you need to say 12 feet tall. I'm going to go over one more and then I'll have you try the last 2. Another way that you can get similar figures in nature is by using shadows. Because the sun hits at the same angle, as long as it's the same time of day. And so these shadows will be corresponding just like the heights are. So you could say the height of the flagpole, the height of the person is proportional to the shadow of the flagpole and the shadow of the person. Cross multiply and solve. You're welcome to move on to the last 2 questions here. Pay attention, the very last one, number 4, you have different units, and so you need to convert them all into inches first. And then convert back to feet. For example, 2, you should get 20 feet tall. Move on to the next 2 whenever you're ready. And if you get completely done and you're confident in your answers, you can go ahead and do your assignment.